Next, we are going to start now the lecture 3 of chapter 2, class 11th mathematics, relations and functions. In this lecture, we will study about the definition of function and some related concepts. So the definition of function we have, if two non-empty sets x and y, these are given to us, x and y, these are two non-empty sets, then we have studied that x cross y, this is the Cartesian product, and any subset of x cross y, we are saying any subset of x cross y, that is called the relation. Now we are talking about a particular type of relation. So we are saying a function is a particular type of relation in which every element in x has a unique image in y. So we are saying, suppose we have two sets, one is the set x and one is the set y. We have elements over here, say 1, 2, 3, and we have elements over here, so it is a, b, c. So we are saying that every element in x, that is we are talking about this one, has an image in y, this 2 has an image in y, and this 3 has an image in y, and the image they have, it is a unique image. Unique image means that corresponding to this one, we have just one image, that the image of this one we have, it is this a. So we are saying we will have a function over here, this is written as f from x to y, and how we write this? We write this that f of 1, that is equal to a, that is the image of 1 under the function f, it is a. Second, we have f of 2, that is equal to a, and third thing we have over here, it is f of 3, that is equal to b. This function, this is defined in this way. So we are saying that every element of this set x is the set, we are saying it is 1, 2, 3. So every element of this set has an image, and it is a unique image. Unique image means we are saying that it is not possible that one has another image over here. So this unique term we are talking about, this will be more clear to you as we will move further in this chapter. So domain of this relation, when we are talking about this relation, we are saying the domain of this relation is equal to domain of this relation f, we are saying that is equal to the set x, that is every element has a unique image, and it is given that no two distinct order pairs in f have the same first coordinates. So we are writing them as ordered pairs 1 comma a, 2 comma a, and 3 comma b. So we are saying that this first coordinate, this cannot be repeated, this cannot be same for any two distinct pairs. And the next thing, this notation is given over here, that if x comma y belongs to f, that is this ordered pair xy, this is belongs to x, we write it like f of x is equal to y. This thing we have already explained in this case, and we read it like that y is called the image of x under the function f, and x is called the pre-image of y. So if we are talking about this particular case, we are saying image of 2 under f is a, and the pre-image of b we have, from this case we are talking about that pre-image of b is 3. So the next thing we have is, if f is a function from x to y, then domain of f is equal to x. Range of f, it is a subset of y. Range of f means, in this case, if we are talking about the range set we have, it is a comma b, and it is a subset of this set y. So we are saying this a comma b, this is the range set of f, and it is a subset of y, and this y is called the codomain of f. So these all terms will be much more clearer to you as we move towards our next examples. So the next thing we have over here, the next term we have over here, it is the image of a subset. So we are saying let f be a function from x to y, and a is a subset of x. Then the image of a under f is defined as, it is f of a is equal to, it is collection of all those fx for x belongs to a. So this example is given over here. We are saying the set x that is given to us is 1, 2, 3, 4. The set y is given to be 1, 4, 9, 16 and 25, and the function that is given to us, the function f that is given to us, it is x comma y. It is the part of the relation we are talking about, and that relation, it satisfies y is equal to x square. So first thing we have is that we have to calculate the corresponding values of y for the values of x. So we are saying we are calculating the values of y. If we put x is equal to 1 in this equation, we will get the value of y is equal to 1. We are substituting the values of x from this set. Next we are substituting x is equal to 2, we will get y is equal to 4. We will substitute x is equal to 3, we will get y is equal to 9. We will substitute x is equal to 4, we are getting y is equal to 16. And it is clear that all these elements, they belong to this set. So first of all, we are talking about, we are proving that f is a function. So to prove this thing, we are saying that every element of this set x, we are looking at this set x, every element of this set x has a image. 1 has the image 1, 2 has the image 4, 3 has the image 9, and 4 has the image 16, and each one of it has a unique image. Each one of it has a unique image means that we are not having like this, that 1 has 2 images. We are not saying that corresponding to 1 there are 2 values of y. It is not the case over here. So this thing gives us that f is a function from x to y. So we have proved that f is a function from x to y. So when we have to prove that f is a function from x to y, it means we have to show that every element of x has an image, and every element of x has a unique image. That it is not the case that for 2 we have 2 values over here. It is not the case like this. Now the domain of this function, that is equal to x. The domain of this function, it is equal to x. The range of this function is these values of y we are talking about, and these values we are saying the range set over here, range of f we have, it is 1, 4, 9 and 16. The range set we have, it is this, and this is a subset of y, and y is called the codomain. Y is called the codomain. Next we are saying, if we want to write the pre-images of the elements of y, then we are saying this 16, it has the pre-image. We are talking about the pre-image of 16. The pre-image of 16 is 4. We are talking about this case over here, that if we look at this number 16, its pre-image is 4. But if we look at this number 25, it has no pre-image. This number 25 has no pre-image. So this thing is mentioned over here. The 25 belongs to y, does not have its pre-image in x. Next, the pictorial image of this function f, it is shown over here. This first circle we are talking about, this is showing the set x that we have. This second is showing the set y we have. These are the elements 1, 2, 3 and 4, and these are the elements 1, 4. So from this relation, what is the relation between this? 1 is related to 1. So this function we are talking about, we can, if we are talking in terms of relation, we are saying 1 is related to 1. Or when we are talking about the functions, we are saying the image of 1 is 1 under the function f. Similarly, image of 2 is 4 under the function f. Likewise, we have shown these relations or functions over here. So this is the representation of this function f. Next is, let we have this set A is equal to 2, 3, 4. Clearly this A is a subset of X. Then if we have to write the value of the image of this set, we want to find the value of f of A, that is image of this set. So what we are going to do is, image of set, we have definition over here, this definition we have. So what we have to do is, we have to take x from A. So x from A means the A set we have, it is first value we are taking x is equal to 2, and we are calculating the corresponding value of f of x, that is equal to f of 2. So the value of f of 2 we have seen over here, that the image of this 2, it is 4. Next we have x is equal to 3, and f of 3 we have, that is equal to 9. Next we have x is equal to 4, and f of 4 we have, that is equal to 16. So these values, these are mentioned over here, that f of 2 is 2 square, f of 3 is 3 square, and f of 4 is 4 square. These are values we have written separately. And what is the definition of f of A? F of A is the collection of all fx for every x belongs to A. So we are saying these elements, this 4, 9 and 16, the collection of all these three numbers, this is the set f of A. So it is important to note over here that when we are talking about the image of an element, when I am talking about the image of an element 1, I am writing the answer, it is 1. When I am talking about the image of the element 2, I am writing the answer, it is 4. But if suppose I am writing the image of the set containing the element 2, the answer is 4. That is image of a subset, it is a set. But when we are writing the image of an element, it is an element in this case. Now next we have is function as a particular case of a relation. So we are saying a relation f from x to y is a function if domain of f is equal to x and no two distinct order pairs of f have the same first coordinates. So we are saying that, suppose we are saying x and y, these are two non-empty sets. We have written the Cartesian product, and then we have taken a subset of this Cartesian product. We are saying R is a subset of this Cartesian product. Then this R will be a function, the elements of R that we have, this x comma y we are talking about, they will be a function, they will belong to f if first condition we have is that the domain of f is equal to x, and second condition we have is that no distinct order pairs in f have the same first coordinates. This is the second condition that we have over here. So we are saying if x comma y belongs to f, we write it like f of x is equal to y. So these are the two sets given to us. One is the set x, that is 2, 3, 4, 5, and second set y, it has the elements 7, 9, 11, 13, 15 and 17, and there is a relation from x to y, and it is defined in this form, that f is equal to xy such that x belongs to x and y belongs to y, with y is equal to 2x plus 3. Now if we list the elements of this relation, we are substituting the values of x from this set in this equation. So first we substitute 2, x is equal to 2, and we obtain y is equal to 7. Next we substitute x is equal to 3, we obtain y is equal to 9. Next we substitute x is equal to 4, y is equal to 11. Last is x is equal to 5 and y is equal to 13. So the ordered pairs now we have it is 2, 7, 3, 9, 4, 11 and 5, 13. These are the ordered pairs corresponding to this relation f. Now domain of this relation, it is 2, 3, 4 and 5. These are the elements of the domain, and domain that is equal to x. The range of this relation, it is equal to 7, 9, 11 and 13. This is the range set of f, and it is a subset of y. Now the second thing we have is that no two distinct ordered pairs in f have the same first coordinates. It is 2, 3, 4, 5. These values, these are not repeated. They have no two have the same first coordinate. So we are saying f is a function from x to y. So this relation that is given to us, it is also a function. Next is let the set A is given. It is -2, -1, 0, 1 and 2. And f is a function from A to z. So the codomain we have over here, that is equal to z, that is the integers. And the function is defined by fx is equal to x square minus 2x minus 3. We have to find the range of f, and we have to write the pre-images of 6, minus 3 and 5. So first of all, we are talking about the values of range of this function we have to write. So we are putting the values of x in this equation. The first value we have to substitute, it is x is equal to -2. So we are calculating f is equal to f of -2. So on substituting f is equal to -2, it becomes -2 square, -2 into -2, -3, and the answer we obtain, that is equal to 5. Next we have to substitute x is equal to -1, and the answer we obtain, it is 0. Next we substitute x is equal to 0, and the answer we obtain, it is -3. Next we substitute x is equal to 1, and the answer we obtain, it is -4. And last we substitute x is equal to 2, and the value of f of 2 we obtain, that is equal to -3. So this function, this can be written in this form, or it can be written in the form that f of -2 is equal to 5, f of -1 is equal to 0, f of 0 is equal to -3, f of 1 is equal to -4, and f of 2 is equal to -3. This function can be written in this form. So now the first thing we have to calculate is the range of f. So range of f is collection of all these elements over here. So the range of f we get, it is equal to this set. It contains 5, 0, -3 and -4. -3 is repeated over here. So we are when we are writing the sets, the repetition is not allowed. So we are writing the elements there 5, 0, -3 and -4. And clearly this is a subset of z, which is the codomain over here. Next, second thing we have to write is the pre-images of 6, -3 and 5. So we want to write we want to find the elements for which the image is, first of all, it is 6. So if we look at these values over here, if we look at these values over here, we are saying there is no x, there is no x for which f of x is equal to 6. This thing is clear from this thing. So there is no pre-image of this 6. So we are saying 6 has no pre-image in A. This is important to note over here, that we are saying 6 has no pre-image in A. That is, when we are talking about the domain set is this, then there is no pre-image. It might be possible that if we take the domain of this as R, there might be a pre-image. So when this domain is given to us, we are saying pre-image means that we want to find an x out of this set A for which f of x is equal to 6. Next we are saying what is the pre-image of minus 3. So minus 3 has the pre-image. When we are talking about minus 3, it is f is equal to 0 and f of 0 is minus 3 and f of 2 is minus 3. So what we are saying over here is that f of 0 that is equal to f of 2 that is equal to minus 3. So the pre-image of minus 3 is, we have two pre-images, it is 0 and 2. So we are saying the pre-image of minus 3 are 0 and 2. Next we have to write the pre-image corresponding to this element 5. We have to write the pre-image corresponding to this element 5. So we are saying which element has this image? We are saying f of minus 2 is equal to 5. So the pre-image of 5 is minus 2. So when we are talking about the functions, every element has a unique image. It means it is not possible to have the values like this, that f of 0 is equal to, that it has two values, that is 2 and 3. This thing is not possible, but it can have two, any element of this set, the range set we are saying, any element of range set, it can have two or even more than two pre-images. Next, the definition we have, it is equal functions. So we are saying two functions f and g are said to be equal if first condition is that domain of both of these functions this is same. Second, the codomain of f and codomain of g that is same. And next condition we have is that at each point of the domain the values of the function they are equal. So we are given two sets over here. One is the set A, that is having the elements 1 and 2. Next is this set B, it is having the elements 3 and 6. We are saying f and g be the functions from A to B defined by f of x is equal to 3x and g of x is equal to x square plus 2. So we have to check whether these two functions, these are equal or not. So both these functions f and g, these are defined from A to B. It means their domain is same, their codomain is same. Now if we write the values of these functions, we are saying corresponding to this function, corresponding to the values of x, we are writing the values fx and gx. So the values of x we have, they are 1 and 2. Now the corresponding values of fx we have, the function fx is 3x. This is the function fx we are talking about. So it is 3 and 6. And the values of gx that we will have over here, that will be, when we are talking about this function, x square plus 2, and we are substituting these values of x over here, the answer we get it is 3 and 6. So what we get is that the value of fx at 1 and the value of gx at 1, they are same. The value of fx at 2 and the value of gx at 2, they are equal. So we are saying that fx is equal to gx for all x belongs to the domain of the function. You can write it is x belongs to domain of f. This is for all, this is symbol for all, that is this thing holds for every element of this set. So we are saying that the two functions f and g, they are equal, they satisfy all the three conditions. Next we have is, let f is a function from R to R and it is defined like fx is equal to x plus 2. So we are saying the domain of f, it is R and the codomain it is R, and the definition that is given to us is that fx is equal to x plus 2. This function g is given from r minus 2 to r. What this r minus 2 means? We are saying from all the real numbers we have removed the element 2, and this is defined like gx is equal to x square minus 4 over x minus 2. This is the definition of gx. So we have to prove that both these functions, these are not equal. So we are saying if we look at the domain of these two functions, the domain of f it is r, and the domain of g it is r minus 2. So that is why we are saying the function f is not equal to g. It is not satisfying the first condition of the equality of the two functions. Now if we look at this function g over here, we can see that this gx that is equal to x square minus 4 over x minus 2, that is equal to x minus 2 into x plus 2 over x minus 2. Now one thing is clear from the domain of this g, that x is not equal to 2. We are saying the elements of the domain of the g, they are all real numbers except 2. It means x cannot be equal to 2. These two terms get cancelled. So we are saying gx is equal to x plus 2 for all x belong to r minus 2. This is our function. So we are saying we have to, the second part of this question it is that redefine f and g such that f is equal to g. So what we have is the function f, we have it is defined from r to r, and fx is equal to x plus 2. The function g is defined from r minus 2 to r, and gx is equal to x plus 2. This thing we have shown over here, that for r minus 2, when x is not equal to 2, we have gx is equal to x plus 2. So what we have to do to make these two functions equal, we have to change the domain of these two functions, we have to make them equal. So to make them equal, we are saying if we change the domain of this function f to r minus 2, why we are writing, we are saying r minus 2, it is a subset of r, it contains all the elements of r except 2. So if f is defined on r, if f is defined on r, it means this implies f is defined on r minus 2 also. So we are saying r minus 2 can be the domain of this function. So if we change the domain of this f to r minus 2, we have changed the domain of this function f to r minus 2 from r, then both these functions f and g, they will become equal. Now the next question we have is this function f is given. So these are how the elements they are related, that f of minus 1 is equal to minus 3, f of 0 is equal to minus 1, and it is given that f of x is equal to alpha x plus beta. So we have to find the values of alpha and beta. So we are substituting f of minus 1, it is given that it is equal to minus 3. So what we get is that minus 3 is equal to minus alpha plus beta. So this thing gives us that alpha minus beta is equal to 3. Second thing we have is, the second thing now we have is f of 0 is equal to minus 1. So what we get is that minus 1, this is the value of f of 0 is minus 1, that is equal to alpha into 0 plus beta. This is the value of x and this is the value of f of x. So this gives us beta is equal to minus 1. So if we substitute beta is equal to minus 1 in this equation, we will get alpha plus 1 is equal to 3. So alpha is equal to 2. So the equation, this equation fx is equal to alpha x plus beta, This is basically we are saying fx is equal to 2x minus 1, which is the required formula. Next we have is let f from R to R be a function, and it is given by fx is equal to x square plus 3. Find the pre-image of each of the following under f. We have to find the pre-image of 19 and pre-image of 2. So when we are talking about the pre-image of 19, it means we are talking about we want to calculate some x for which f of x is equal to 19. It means we are talking about x square plus 3 should be equal to 19. So we get x square is equal to 16. So this gives us x is equal to plus minus 4. So we are saying there are two pre-images of 19 mentioned over here, that minus 4 and 4, these are the two pre-images of 19. That is the function that we have for it. F of 4 is also equal to 19 and f of minus 4 is also equal to 19. Next is we have to calculate the pre-image of 2. So we are writing it is x square plus 3 should be equal to 2. That is f of x should be equal to 2. So what we get is that x square is equal to minus 1 and there is no real value. So x does not belong to R. There is no real value for which x square is equal to minus 1. So we are saying 2 does not have any pre-image under f. Why? Because the domain of this function, it is R. So we are saying that x, there is no real value x. So we get that 2 does not have any pre-image under f. The next definition we have, it is inverse of a function. So we are saying let f from x to y and let y belongs to y. There is a function f from x to y and there is an element y in y. Then the inverse function we are talking about, the inverse of this f, it is equal to all those x for which f of x is equal to y. That is the inverse function when we are talking about, it is set of pre-images of y. And the inverse function, it is written like this, that it is f inverse. The similar definition we have done in case of relations. So some examples they are given over here. We are talking about fx is equal to x square 1. This is a function from R to R. The domain and codomain, they are real numbers. Now we have to first calculate the value of f inverse of minus 4. So when we are talking about f inverse of minus 4, it means we want to calculate the value of x for which fx is equal to minus 4. We have x square plus 1 is equal to minus 4. So x square is equal to minus 5. And this gives us that x does not belong to R. There is no x for which x square is equal to minus 5. So we are saying this set, this is equal to empty set, that there is no pre-image of this set minus 4. Next is f inverse of minus 10. So we are writing f inverse of 10. It means we want to calculate the value also of x for which fx is equal to 10. So this implies us that x square plus 1 is equal to 10. So this implies us x square is equal to 9. So this implies us x is equal to plus minus 3. So what we get is that the collection, the pre-image set of this set 10, it is 3 and minus 3. So this is the inverse f inverse of 10, that is equal to 3 and minus 3. Next we have to calculate is f inverse of 5 comma 17. So to find this, we are saying we have to calculate the value of x for which fx is equal to 5 and fx is equal to 17. So we have calculated these values over here. We are saying x square is equal to 5 and x square plus 1 is equal to 17. And on solving this value, we will get x is equal to plus minus 2, x is equal to plus minus 4. So the values of x for which fx is equal to 5 or 17, the collection we can write it is f inverse of 5 comma 17, that is equal to minus 2, 2, minus 4 and 4. So this is the inverse image of this set. Next we have, let f is a function from R to R defined by fx is equal to 1 when x is a rational number, and it is equal to minus 1 if x is not a rational number. Q means a rational number we are talking about. So what we have is, if we have to calculate the value of f of 1 by 2, how we are going to write the value of f of 1 by 2? 1 by 2 is a rational number, and we know that if x is a rational number, the answer we obtain, that is equal to 1. So we are writing the answer over here, it is 1. Next, when we are talking about f of 0.34, again this number is a rational number. So the answer we are obtaining in this case, again it is 1. Next we have f of square root 2 and f of pi. What we have is square root 2 and pi, both of these are irrational. So we are saying x does not belong to R means x is not a rational number, it means it is an irrational number. And when x is an irrational number, we are saying the answer we will obtain, that is equal to minus 1. So we are saying whenever we substitute the irrational numbers as x, the answer of this function gives us, it is minus 1. And whenever we substitute the value of this function as a rational number, the answer we get, it is equal to 1. So what we can see is that this function is just like a machine, that we are giving it some values from the set x, that is the domain of this, and we are getting some answers over here. So first of all, if we have substituted the value 1 by 2, we have put the value 1 by 2 in this machine, the answer we have obtained, it is equal to 1. If we have substituted the value pi in this machine, the answer we are getting, it is minus 1. So function is just like a machine to which if we give the values from the domain set, it will process that value and will give us the answer, and the answers we are saying they are constituting the range set. So the range, next thing we have to calculate over here, the range and domain of this function. The range of this function, that will be the collection of all the answers that we have. So we are saying there are only two possible answers, that if x is rational, answer is 1. If x is irrational, the answer is minus 1. So the range set of this function, it is equal to 1 and minus 1. So this is the range of this function. These are the only possible answers that we can have. Next thing we have to do is we have to calculate the value of f inverse of 1. F inverse of 1 means we want to calculate those values of x for which fx is equal to 1. The function that is given to us is fx is equal to 1 if x is a rational number, and it is minus 1 if x is a not a rational number or x is an irrational number. So we are saying we want to calculate those x for which x is equal to 1. So those x, they are q. So we are saying that f inverse of 1, that is equal to q. That is the pre-image of this set 1. It is the set of rational numbers, and pre-image of this set minus 1, this is, we are saying the image of f will be minus 1 for all irrational numbers. So it means this r minus q means that x does not belong to q, but x is a rational number. It means it is representing the set of irrational numbers. So these are the pre-images of the set 1 and pre-image of the set minus 1. Now the next we have this function f is given. It is defined from R to R, and the definition is fx is equal to 3x minus 2 when x is less than 0. it is 1 when x is equal to 0, and it is 4x plus 1 when x is greater than 0. So how you can look at this function? We are saying it is a machine over here. There are three parts in this machine. When x is less than 0, this element will be sent to this part. When x is equal to 0, this element is sent to this part. And when x is greater than 0, this is sent to this part. What it is going to do when it is less than 0, it will process it like 3x minus 2. When it is equal to 0, it will give the answer 1. And when it is greater than 0, it will process it like 4x plus 1. Now suppose we have given it the first value, say x is equal to 2. This value will be sent to this part of the machine because x is greater than 0. So the answer we will obtain, that will be equal to 4 into 2 plus 1, that is equal to 9. Next is, if x is equal to minus 2, so this will be sent to this first part of the machine. The answer it will give us 3 into minus 2 minus 2, that is equal to minus 8. So this will give us the answer as minus 8. Next, it is, if we are giving the value 0 to this, it is going to this middle part, and the answer we obtain, that is equal to 1. If we are substituting the value f of 3.5, so it will, 3.5 is greater than 0, it will go to this part. It will be processed like 4x plus 1. In place of x we have, it is 4 into 3.5 plus 1, and the answer we obtain, that is equal to 50. So this is how these kind of functions they are working. Next is, we are saying the next function that is given to us is, it has two parts over here. This function we have, it has basically two parts. First is, if the value of x lies between 0 and 2. Second is, the value is greater than 2 and between 2 and 10. If the value lies between these two values, the function behaves in this way, it is x square. And when it is this value, it is behaving like 3x. So if we feed this function the value 2, it is given that the domain of f, it is 0 to 10 closed interval. Now we are saying, if we feed the value 2 to this function, then what will happen over here? If we are substituting the value 2 to this function, look at this condition. When x is less than equal to 2 is there. When x is less than equal to 2 is there. So it means this can go to any one of these two. Suppose it is going, we have sent this to this first part of this machine. The answer we are obtaining, it is 2 square, that is equal to 4. This can also go to the second part of the machine, and the answer we are getting over here, that is 3 into 2, that is equal to 6. So what we get is that f of 2 has two values, 4 and 6. So this thing is not possible, because by the definition of the function, we have that every element should have a unique image. It is not possible to have two images. So that is why we are saying that f is not a function. It means this function, that this term that is given to us, or expression that is given to us, this is not a function, because it is returning us two values corresponding to this value 2. So even for, we are getting that even for one value, if it is given two answers, it is not a function. Next is, this gx is given, it is x square and 3x. It is x square when 0 is less than x is less than equal to 3, and it is 3 is less than x is less than 10. So we are saying the domain, suppose it is gx is equal to 0 to 10, closed interval is given. This is interval given to us, and it is the closed interval. It means it can take any real value between 0 to 10. Now we are saying every element in 0 to 10 is associated with a unique number under this image G. Why we are saying so? Suppose we are taking any number between 0 to 3. We are dividing this in two parts. We are saying if we put any number between this to this, it will have a unique image x square. If we put any number greater than 3, it will have a unique answer, that is 3x. So we are left with the case x is equal to 3. When x is equal to 3, we are saying gx will have value. Again, this x is equal to 3 can go to this first part, it can go to this second part also, because it is equality on both these parts. It is equal to sign in both these parts. So we are not sure that it should go to this or it should go to this. So we find the answer with both these cases. So with the first case, we will get the answer, it is 3 square, that is equal to 9. From the second, we are getting it is 3 into 3, that is equal to 9. So we are saying basically the value of g of 3, that is equal to 3. It means for the value x is equal to 3, this gx has a unique value, and for every element of this domain, it has a unique answer. So we are saying this gx is a function. This gx is a function. Now, if suppose, again we come to this second part over here, we are talking about this second part. If suppose I remove this equality sign from this portion, I am writing this function fx is equal to, it is x square when 0 is less than equal to x is less than equal to 2, and it is 3x when 0 is less than equal to, this is not 0, it is 2 is less than x is less than equal to 10. What change we have done over here? We are saying we have written 2 is less than x. Earlier it was 2 is less than equal to x. Now this will become a function. This problem will be solved, that 2 will not have two images over here. Then this will be a function, but this is not a function over here. Next is a set A is given. It has two elements 1 and 2, and a set B is given. It has three elements 2, 4 and 6. We are saying let f be the set. It is consist of all ordered pairs x, y, where x belongs to A, y belongs to B, and y is greater than 2x plus 1. We have to write f as a set of ordered pairs. So we are saying y is greater than 2x plus 1. So we are substituting different values of x over here. So when we substitute x is equal to 1, we are saying y is greater than 3. Y is greater than 3 means both 4 and 6 they are related to 1. We can have the value of y is equal to 4 or y is equal to 6. So we have 1 comma 4 and 1 comma 6. These are the two elements corresponding to 1. When we are substituting x is equal to 2, we get y is greater than, we substitute this value over here, it is 5. So we get the value of y is equal to 6. So the number we have, it is 2 comma 6. So we are saying the value of f we have, it is 1 comma 4, 1 comma 6 and 2 comma 6. Clearly this 1 has two images. So this is not a function. Next is let A is equal to 0, 1 and 2. B is equal to 3, 5, 7, 9. And this set F is given. This is the ordered pair that is given to us. Y is equal to 2x plus 3. So we are writing these values of, for x is equal to 0, y is equal to 3. For x is equal to 1, we have taken these values of x from here. For x is equal to 1, y is equal to 5. For x is equal to 2, the value of y we have, that is equal to 7. So clearly we have that every element of this domain set has an image and their image is unique. I think their image is unique. So this f is a function from A to B. We have to find the domain and range of this f. This f, it is represented in this form over here. So the domain of f, that is equal to a, and the range of f, that is equal to 3, 5 and 7. This is the range of f that we have. Next question we have is, if f is equal to x square, find the value of this term. So it is f of 1.1 minus f of 1 over 1.1 minus 1. So f of 1.1 means the value of, in place of x we are writing it is 1.1, so answer it is 1.1 square. So it is 1.1 square minus f of 1 is 1.1 over 1.1 minus 1. So the answer we are obtaining it is 1.1 plus 1, that is equal to 2.1. So this is the value of this function at of this expression. Next we have is, let a set A is given. The elements of this set, they are 12, 13, 14, 15, 16 and 17. And a function f is given from a to z. That is the set of integers. And it is defined like fx is equal to highest prime factor of x. We have to find the range of f. So we are saying if we substitute different values of x, the values of x we have it is 12, 13, 14, 15, 16 and 17. So if we write the prime factors over here, the highest prime factor of 12, the factors of 12, they are 1, 2, 3, 4, 6 and 12, and the highest prime factor it is 3. For 13 the highest prime factor is 13. For 14 the highest prime factor is 7. For 15 the highest prime factor is 5. For 16 the highest prime factor is 2. And for 17 the highest prime factor it is 70. So we are saying the image sets we have it is f of 12 is 3, f of 13 is 13, f of 14 is 7, f of 15 is 5, f of 16 is 2 and f of 17 is 17. So we have to write the range set over here. So the range set has the elements, it is 3, then 13, then 7, then 5, then 2 and last 17. Next question we have is, let f is a function from R to R and it is given that fx is equal to x square, and g is a function from C to C. C is the set of all complex numbers. We will study in our next chapter. We have to show that f is not equal to g. So clearly we have is that the domain of this f it is R, the domain of this g it is C. So the domain of both these functions, they are not equal. So this implies us that f is not equal to g. That is, both the functions, they are not equal to each